Hello, I'd like to talk to you a little in this video about mathematics, and in particular I'd like to talk about simultaneous equations. A specific form of that's called linear equations. That's what these are. These are called linear equations because the variables x and y are not to any power and they don't appear multiplied by each other. Right? In fact, there's a whole field of mathematics called linear algebra that deals with this stuff. And we're not going to go into that. But what I want to show you is if you solve these equations, number one, if you solve these equations, you get those two numbers. Let's get that out of the way. There are three separate but mathematically equivalent ways to do this. And I want to show you how you get the same answer with each one of these. All right? So the first way we all learned in maybe junior high school is called substitution. Right? That's where you manipulate one equation and you substitute it into the other one. Well, since I made these up, I know this one's the easy one to work with. So let's start with equation B here. That's 4x minus 4y equals 1. And let me write that out a little differently here. 4y equals 1. Let's see, 4y equals 4x minus 1. How's that? All right? And what I can do now is I can divide through by 4. Try this again here. Okay, and so I get x minus a quarter. Right? So that's just this equation rearranged. Now, the nice part about this is I have x in terms of y. What I can do now is go to this equation. Everywhere I see a y, I'll put that in because y and this thing in the circle are the same thing. Right? So if I do that, I'll say 3x plus 5 times everything in there equals 2. Right? So let's expand this out a little bit. Okay, there's that. I'm running out of room down here, so I'm going to move up here. Okay, and I get 8x equals, and if I work all this out, I'm going to get, let's see, 13 over 4. I'm in a hurry, so you can figure this out. And x is going to be equal to 13 over 32, which equals that, 0.406. And if I were to take that and substitute it into one of these two and solve for y, I get that. Right? That's substitution. We all probably know how to do this. There's another way, which is graphical. Okay? Graphical just means drawing a picture, so let's do that. We're going to graph two equations. Now these don't maybe look like straight lines, but that's what they are. Let's take this one. We just found out that y equals x minus 1/4. Well, remember when you saw y equals mx plus b, okay, where m is the slope and b was the intercept? Well, there's the slope, slope's 1. There's the intercept. Right? Let's plot this real quick. If x equals 0, then y equals minus a quarter. So let's see. Let's on this axis right there, where each of these tick marks is a half. That's what that looks like. And let's see. If x equals 1, then y equals 3/4. So x equals 1, y equals 3/4. We'll go over, and that's about it right there. So I've got 2 points. Well, if I have 2 points on a line, I know everything there is to know about that line. So I'm going to just eyeball this in here. Okay, that's, approximately straight. So there's that equation. That's B. Let's go look at A now. If I look at that, let's see, 5y equals 2 minus 3x. Okay, so far so good. I subtracted 3x from both sides. And y equals, let's see, 2 over 5 minus 3 over 5x. All right, and I'm going to write that out one more time in this y equals mx plus b form. And y equals minus 3 over 5x plus 2 over 5. Okay, same thing. There's the slope. Slope's negative now, so it's going to slope down as I go to the right. Plus 2 over 5. Well, if x equals 0, then y equals 2 over 5, which is 0.4. So we'll call that maybe right there. If x equals 1, then I get minus 3 over 5 plus 2 over 5, which is minus 1 over 5 minus 0.2. So right there, let's call, I don't know, that looks like minus 0.2. Right. See that point right there? That's the solution. That's the point in x and y. Should be right there. That looks like about 0.406, about 156.156. I'm sketching this in, so that looks pretty close. That's the point at which these two lines cross, the two lines defined by this equation and this equation, which are really this one and this one, right? That's the second way to do this. Now, the third way to do this is using something called linear algebra. Now, linear algebra is really equivalent to substitution, but it looks a little different. It handles a little different. It's important here because that's the way computers want to think about this equation. And that's the way your graphing calculators, your TI-89 or whatever it is you use, also wants to think about this. So let's learn how to write this out. Okay? So we got graphical. Let's do linear algebra. It's actually called matrix algebra, so we'll just write matrix here. Now, the matrix is just a block of numbers. This isn't Matrix the movie. I'm probably the last guy on earth who never saw the Matrix. So what I'm going to do here is I'm going to write this down in a slightly different form, okay? I'm going to take, on the left side of the equation, these four numbers here, 3, 5, 4, and minus 4, and I'm going to write them down as a block, and I'm going to write these as a list, and I'm going to write those two variables, x and y, as a list, and I'm going to write them in a very specific form. So I've got 3, 5, 4, minus 4 in this block. That's called a matrix. And I'm going to write x and y as a list of numbers. This is called variables in this case. This is called a vector. A vector is just a matrix with one column. And I'm going to write the numbers on the right side of the equal sign also as this list of numbers. And this will be 2 and 1. That's also a vector. They're different vectors, but they're vectors. Okay. Now, mathematics is kind of neat. It doesn't really care what kind of numbers you use. Operations are defined for all of them. I can add real numbers. I can add imaginary numbers. I can add fractions. I can add decimal numbers. I can add irrational numbers. Turns out I can add matrices and I can add vectors. Now, sometimes the rules are a little different, but it's still just addition. Okay. So what I'm going to do here is I'm going to write out this matrix. I'm just going to call it A. I can name mathematical entities if I want, like x and y are just numbers. Don't happen to know what they are, but they're numbers. Okay, so A, and I'm going to call this capital X, if I can write it, equals B. Okay, so there we go. There's AX equals B. Well, that doesn't look too hard to solve, and it isn't. All you have to do is write out, I'm going to write it over here, a to the minus 1 times b equals x. And x is this list of variables. That's what you want to solve for. Well, that's how your computer thinks about it, and that's how your calculator thinks about it. Now, I'm about out of time here, so I'm going to use the next video to talk a little bit more about this. But this is called matrix form. It's for our intents and purposes right now, this is really just a notation for writing things down. If you get real into it, it's actually a lot more than that. But this is how calculators and computers want to think about this problem, and there's how to solve them.